Is multiplication commutative? Let us verify that using a graph paper. Let us multiply any two whole numbers in two different orders and check whether the product is same. Now let us mark two rectangles, one rectangle with 4 cross 3 and another rectangle with 3 cross 4. In 4 cross 3 rectangle, number 4 represents 4 rows. So you need to create 4 rows and number 3 represents 3 columns. So you need to create 3 columns now. In order to find 4 cross 3, mark a rectangle with 4 rows and 3 columns. And finally count the number of squares in it. In 3 cross 4 rectangle, number 3 represents 3 rows. So you need to create 3 rows now and number 4 represents 4 columns. So you need to create 4 columns. In order to find 3 cross 4, mark a rectangle with 3 rows and 4 columns and finally count the number of squares present in it. In order to count the number of squares present in each rectangle, you must know what a small square represents. Let a small square represents 1 unit of area. So when you see a small square, then you need to count that as 1. Let us count the number of squares in first rectangle, that is 4 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 squares in 4 cross 3 rectangle. So 4 cross 3 equals 12. Let us count the number of squares in second rectangle, that is 3 cross 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 squares again in 3 cross 4 rectangle. So 3 cross 4 equals 12. If you look at both rectangles, that is 4 cross 3 and 3 cross 4, both of them have 12 squares. From this we can conclude 4 cross 3 equals 3 cross 4, that equals 12. From the above example, we find that in whatever order we multiply any two whole numbers, their product remains the same. In other words, if A and B are any two whole numbers, then A cross B equals B cross A. This is called commutative property of multiplication.